All right, so we're diving into some new AI research today,
Mhm.
and this one is pretty dense. So
Oh,
I'm
yeah.
gonna try my best to like break it down. But
Let's do it.
it's about this new model called Kimi k1.5,
Okay.
and it's multimodal, which is interesting in itself. But the real like hook here
Mm-hmm.
is the way that it learns.
Right.
And I know you're big on the whole AI learning thing. So
Absolutely, yeah. How AI can move beyond just like static data and actually learn through experience.
yeah, like more like how we learn.
Exactly, like trial and error and figuring things out on its own.
So Kimi uses something called reinforcement learning,
Right.
which if you've listened to the show before, you'll probably remember. It's like basically a reward system.
Yeah, it's like giving the AI a little treat every time it gets something right, so it learns to do more of those things.
Like, and this lets it tackle some pretty complex problems, right?
Yeah, they've been testing it on things like math and coding, even image understanding. But what I find really interesting is how its performance actually increases the more it's allowed to think things through.
Is that right? Like actually like brainstorm with itself. I'm picturing like little AI with a whiteboard.
Uh-huh. Yeah, kind of like that. It's this chain of thought prompting they use, or COAT for short,
Okay.
where it breaks down problems step by step, kind of like showing your work in math class, you know?
Okay.
And what they found is that letting those cookies get really long, like up to 128,000 tokens.
Whoa, that's a lot of text.
It is.
Oh.
But that actually boosted Kimi's accuracy on some pretty hard problems like advanced math competitions even.
Wow. So longer chains of thought lead to better results.
Hmm.
Huh. I mean, that's pretty wild. But also, isn't that like incredibly inefficient? How could that ever be practical, like in a real world setting?
That's a great question. And the researchers actually thought about that too. They found ways to compress Kimi's long COAT thinking into a shorter process.
Oh, really?
They call it long to short distillation. It's like distilling the essence of its thought process, you know?
So like teaching a smaller AI to think like the long Coty version, but without all the extra steps.
Yeah, exactly.
That's pretty clever.
Yeah.
Makes me wonder how Kimi stacks up against those like massive AI models with tons of processing power, you know? Is it a case of brains over brawn or what?
It's fascinating, actually. While larger models might start off stronger, Kimi, with its long COT process, can actually catch up in performance.
Huh. So sometimes strategic thinking can actually beat brute force.
Yeah.
Even in AI.
It seems that way, yeah.
That's pretty encouraging.
Yeah.
Means we don't necessarily need ever larger models to make progress. But learning takes more than just thinking right. It also takes feedback. How does Kimi handle being wrong? Does it get penalized like some other AI systems do?
Well, this is where things get really interesting. They found that punishing Kimi for wrong answers wasn't always the best strategy.
Wait, so you're saying they let it make mistakes and just like keep going?
Sometimes, yeah. Because those errors actually helped Kimi learn how to course correct and develop better problem-solving strategies.
Whoa, so it's like those wrong turns can actually lead to a deeper understanding in the long run. Makes you think about the nature of learning itself. Huh.
Exactly.
For both AI and us.
Yeah.
But, okay, to get to that level of understanding, Kimi must have needed some serious training data. What kind of stuff they throw at it?
They went all out. Math questions from textbooks and competitions, coding challenges, even images paired with text.
Really? Images, too?
Yep. And they even built a special sandbox to safely run and test the code Kimi generated.
Oh, wow. So it wasn't just theoretical. They actually let Kimi loose in a controlled environment to see what it could do.
Exactly. They wanted to make sure it wasn't just coming up with solutions on paper, but that those solutions actually worked in practice.
That's a pretty rigorous approach. And speaking of data, you know, how crucial that is. But what makes Kimi's training data stand out? What did they do to make sure it was learning from the best possible sources?
Quality control was a huge focus. They had multiple levels of filtering to weed out things like duplicate content or poorly translated text. Even potential bias was something they were very careful about.
Oh, yeah, that's important.
They used some pretty sophisticated algorithms and techniques to ensure Kimi was learning from a diverse and high-quality data set.
So it's not just quantity, it's quality.
Exactly.
Now, Kimi is multimodal, right? Meaning it can handle both text and images. That implies a pretty complex training process. Did they train it on both types of data simultaneously?
They actually used a multi-stage approach, which is pretty clever. First, they focused solely on language data, so like building a strong linguistic core.
Okay, so it's like learning to read before you learn to interpret paintings.
Exactly. And once Kimi had a solid grasp of language, they gradually incorporated vision language data.
Interesting. So like learning to read a picture book where the images and text work together.
Right.
I'm starting to see how this staged approach could lead to a deeper understanding. It's like building a house brick by brick. But this whole process, all those steps and layers, must take a ton of computational power. What's going on under the hood of Kimi that makes it all possible?
Well, at its core, Kimi is based on a variant of the transformer decoder.
Ah, transformers. I've heard of those. They're behind a lot of the recent breakthroughs in AI, right?
You got it.
But remind me what makes them so special. How does that architecture help Kimi learn and solve problems in such a sophisticated way?
Transformers have this incredible ability to focus on the most relevant parts of the input data, whether it's text or visual information.
Okay.
They use a mechanism called attention to sift through all that data and identify the key elements.
Like a student highlighting the important passages in a textbook.
Exactly.
That makes sense. It helps Kimi cut through the noise and focus on what truly matters. But I'm guessing attention is even more crucial for Kimi because of its ability to handle those long chains of thought right.
Absolutely. That attention mechanism is what allows it to process those extended sequences of information without getting bogged down. It can efficiently skim through massive amounts of data and extract the key ideas and relationships.
It's like having a superpower for information processing. But with all these sophisticated features, the training process must be pretty complex. Didn't you mention there were 3 distinct stages?
You have a great memory. So after that initial language-focused stage, they move on to what they call the vision-language cooldown stage. Think of it as a consolidation phase where Kimi is trained on high-quality data sets, both text and visual, to refine its skills.
So it's like practicing and honing what it's learned so far.
Exactly. And they actually use some synthetic data in this stage, too.
Synthetic data. Remind me what that is again.
It's artificially generated data.
Right, right. But what's the advantage of using that? Why not just stick with real-world data?
Well, synthetic data allows the researchers to target specific areas where Kimi might need more practice. They can custom design data for things like math problems or knowledge-based tasks or code generation.
So it's like giving Kimi extra homework in the subjects where it needs a little more help.
Exactly.
Love that analogy. So what about the third and final stage of training? What happens after the cool-down phase?
This is where things get really exciting. It's called the long context activation stage, and it's all about training Kimi to handle those extended sequences of information we talked about earlier, those really long chains of thought.
Ah, so this is where Kimi learns to think big, to process like entire books instead of just paragraphs.
Precisely.
But how on earth does it manage to handle that much information without getting completely overwhelmed? That must be a computational nightmare.
It's pretty remarkable. This is where that transformer architecture with its attention mechanism really shines. Kimi can effectively skim through a massive amount of text and identify the key ideas and relationships without getting lost in the details.
It's like having a superhuman ability to absorb and synthesize information. By the end of these 3 stages, Kimi must be a truly formidable AI. But how do we know it actually works? How did the researchers measure its performance and compare it to other cutting-edge systems?
They put Kimi through a battery of tests, a whole gauntlet of benchmarks designed to evaluate its abilities across a wide range of tasks and modalities.
Okay, so like the AI equivalent of the Olympics.
You could say that. They use benchmarks like MMLU, IFEval, CELO EWSC, and CEVAL to assess its text-based skills. And for coding, they had Human Eval Mool and Live Code Bench.
Those are some pretty intense names. And I'm guessing they didn't go easy on the math benchmarks either, right?
Definitely not. They had AIM 2024, Math 500, even Math Vision and Math Vista to test its visual reasoning abilities.
Okay, so we're talking about a truly comprehensive evaluation here. Kimi was really put through the paces. Now, as an AI enthusiast myself, I'm dying to hear how Kimi performed on all these benchmarks. But I think we've covered enough ground for one segment. Let's take a quick break and come back to delve into those results. I have a feeling they're going to be pretty impressive.
I think you're right about that. All right, so are you ready to hear how Kimi did on those benchmarks?
Oh yeah, I'm on the edge of my seat. Lay it on me.
Well, let's start with those language-focused tasks. On the MMLU benchmark, Kimi actually outperformed a lot of the leading language models out there.
Is that right?
Yeah, it showed a really broad and deep understanding of all sorts of subjects like science and tech history, even literature.
So it could like hold its own in a trivia competition? That's pretty impressive. But what about its ability to actually like follow instructions and execute commands? Those are pretty crucial skills for any AI that's going to be useful in the real world, right?
Absolutely, and that's where the IFEval benchmark comes in.
Okay.
Kimi excelled there too. Showed a remarkable ability to understand and carry out complex instructions accurately and efficiently.
Okay, so starting to sound like a pretty versatile AI.
Oh.
But Didn't you mention Kimi was also evaluated on its Chinese language skills? That's really interesting to me. As someone who's, interested in the global impact of AI, how did it perform on those tasks?
Kimi proved itself to be a true polyglot. It showed a strong grasp of Chinese language nuances and complex reasoning abilities on both the CLULSC and C-EVOL benchmarks.
Wow, a multilingual AI. That
Yeah.
opens up so many possibilities, right? For cross-cultural communication and collaboration.
Absolutely.
But let's be honest, a lot of the excitement around Kimi is focused on its problem-solving abilities, right? Especially in math and coding.
Mm.
How did it fare on those challenging benchmarks you mentioned earlier, like human evil mole?
Ah, yes, human evil mole. That one's designed to test code generation in multiple programming languages, right?
Yeah, basically, can an AI actually write working code? That's the big question.
Well, Kimi didn't just pass the test, it excelled. It generated functional code across multiple programming languages, showed a real ability to tackle those real-world coding challenges that, programmers face every day.
Wow, that's starting to sound like Kimi could give human programmers a run for their money. But I know you're always pushing for rigorous evaluation, right? One benchmark is never enough. What other coding benchmarks did Kimi face?
You're absolutely right. We need to make sure the results are reliable and robust. So they also evaluated Kimi on Live Code Bench.
Okay, I've heard of that one.
Mm.
Isn't it designed to be even more comprehensive and to prevent something called data contamination?
Exactly. We don't want the AI to just be memorizing answers. We need to make sure it's actually demonstrating real understanding and problem-solving skills.
So, they made sure Kimi couldn't just parrot back solutions it had seen before.
Yeah.
It had to actually think for itself. That's pretty clever, but how did it do?
On Live Code Bench, Kimi consistently outperformed other models, showed a remarkable ability to learn and adapt to new coding scenarios.
Okay, you've convinced me Kimi is a coding whiz. But those math benchmarks you mentioned earlier, those were pretty intimidating too. Like AIM 2024, wasn't that based on a prestigious high school math competition?
It is, and those problems would stump most adults, I'd say.
Yeah, I was never a math whiz myself. So I'm really curious how Kimi performed on those.
Well, Kimi tackled those head-on and achieved scores that rivaled those of top-performing high school students.
Wow.
It clearly demonstrated a mastery of complex and abstract mathematical concepts. It wasn't just about crunching numbers, it was about understanding the underlying logic and reasoning.
So Kimi is basically a math prodigy. But to really test its abilities, you need a benchmark that's both comprehensive and challenging, right? Did Kimi face anything like that in the math domain?
Absolutely. That's where Math 500 comes in. This benchmark covers a wide range of math topics and difficulty levels, provides a really robust test of Kimi's mathematical capabilities.
Okay, enough suspense. How did Kimi do?
Kimi consistently scored high on Math 500, confirmed its mastery of a diverse set of mathematical concepts and problem-solving techniques.
Well, it really sounds like Kimi is much more than just a calculator. It's demonstrating a deep understanding of math that goes way beyond simple arithmetic.
Hey.
That's incredible. But all of these benchmarks we've talked about so far have been in controlled environments, right? How do we know if Kimi can actually perform in a real-world setting against actual human competitors? Did the researchers explore that at all?
They did. Remember Code Forces, that online platform for competitive programming?
Yeah.
They actually pitted Kimi against human programmers on this platform to see how it would fare in a real-world competitive coding environment.
Whoa, that's like throwing Kimi into the deep end of the pool. How did it manage against those seasoned human programmers?
It performed remarkably well, holding its own and earning a respectable ranking. It's clear that Kimi's coding skills aren't just theoretical. They're practical and applicable in a real-world setting.
That's incredibly exciting. But Kimi is a multimodal AI, right? Meaning it's supposed to be able to handle both text and images. We've heard all about its linguistic and mathematical prowess, but what about its visual reasoning abilities? Did the researchers evaluate those as well?
Of course. They used a set of benchmarks specifically designed to test Kimi's ability to understand and reason about information presented in both text and visual formats.
Okay, so like those K1.5 tests that humans have to solve to prove they're not robots, but obviously something much more sophisticated than that.
Much more sophisticated, but you're on the right track. They used benchmarks like MMU, which stands for Massive Multidiscipline, Multimodal Understanding and Reasoning.
Yeah.
to assess Kimi's ability to integrate information from both text and images, a skill that's crucial for any AI that needs to interact with the real world.
All right, so MMMU tests whether Kimi can handle the kind of mixed media information we encounter every day.
Right.
Right, from textbooks with diagrams to websites with images and text.
Exactly.
How did it perform?
Kimi excelled on MMMU, showed a true mastery of multimodal understanding and reasoning. It could seamlessly integrate information from both sources, demonstrating a level of sophistication that's rarely seen in AI systems.
That's truly impressive. But I'm guessing they didn't stop there. Did they also evaluate Kimi's ability to solve math problems that involve visual elements, like those tricky word problems with diagrams or graphs that we all struggled with in school?
They absolutely did. They used benchmarks like MathVision and MathVista for that. These benchmarks are specifically designed to test an AI's ability to understand visual information in a mathematical context and use that information to solve problems.
So it's like testing whether Kimi can see the math, not just compute it. That's fascinating. How did it do?
Kimi aced those benchmarks as well. It could accurately interpret the visual information, connect it to the relevant mathematical concepts, and arrive at the correct solution.
That's remarkable. It really sounds like Kimi is exceeding expectations across the board. As someone who's been following AI research for years, are you surprised by these results?
I have to admit, even I'm a little awestruck by Kimi's performance. It represents a significant leap forward in AI capabilities, and it's a testament to the incredible work of the researchers who developed it.
It sounds like Kimi is really pushing the boundaries of what we thought was possible with AI. But I know you're always thinking about the bigger picture. What do these impressive results tell us about the future of AI? And what does that future mean for us, for society as a whole?
Those are the big questions, aren't they? And I think Kimi's emergence is a sign that we're entering a new era of AI, one where these systems are becoming increasingly capable of tackling complex human-level tasks. But it also raises some profound questions about the role of AI in our lives and the potential impact, both positive and negative.
We've covered so much ground in this deep dive, and I'm really eager to explore those bigger questions with you. But for now, let's take a short break to let all this information sink in. We'll be right back to delve into the implications of Kimi's success and what it means for the future of AI. Welcome back to our deep dive into Kimi k1.5. We've gone through all the technical stuff, the architecture and the training and those impressive benchmark results.
Yeah, it's been a wild ride.
But now I want to kind of shift gears and talk about the bigger picture.
Absolutely. I think Kimi's emergence really signals a potential turning point in AI.
It does make you think about what these systems can achieve and what that means for us as a society.
It's both exciting and a little bit unsettling, right?
It is. Like, on one hand, it's thrilling to see AI breaking new ground and exceeding expectations. Like, as someone who's always been fascinated by technology, I find it incredibly inspiring.
Yeah, to see AI tackling challenges that were once thought to be exclusive to human intelligence. It's amazing.
But there's also this sense of unease.
Yeah.
Like, what does this rapid progress mean for our roles, our jobs, even our sense of identity as humans?
I think those are valid concerns. It's important to acknowledge both the excitement and the apprehension.
Absolutely. So let's start with the positive. What are some ways Kimi and similar AI systems could actually benefit humanity? I'm talking about real-world applications here.
Well, the potential is vast.
Yeah.
Imagine AI assisting doctors in diagnosing diseases earlier and more accurately.
Oh, yeah. That would be amazing.
Leading to more effective treatments and better health outcomes.
Right. What about education?
AI could personalize education, tailoring lessons to each student's needs, making learning more engaging and effective.
That would be revolutionary. And what about tackling some of the world's biggest problems like climate change or poverty? Could AI play a role there?
Absolutely. AI could help develop more sustainable energy sources, optimize resource allocation, even predict and mitigate natural disasters.
The possibilities are really endless. But let's not shy away from the potential downsides either. What are some of the risks we need to be mindful of as AI continues to advance?
One big concern is misuse. Like any powerful technology, AI could be exploited for malicious purposes.
Right. Like what? Give me an example.
Developing autonomous weapons or spreading misinformation on a massive scale, we need safeguards and ethical guidelines to prevent that.
Absolutely. And then there's the economic impact. A lot of people fear that AI will automate jobs leading to widespread unemployment.
It's a valid concern. Investing in education and retraining programs is crucial. We need to equip people with the skills they'll need in a future job market that's heavily influenced by AI.
Right. It's not just about replacing jobs. It's about creating new ones and making sure everyone benefits from these advancements.
Exactly. And we also need to think about the impact of AI on human creativity and purpose.
Yeah, that's a big one. If machines can create art and music and write stories, what does that mean for human expression?
It's a profound question. I don't believe AI will ever truly replace human creativity, but it will undoubtedly change it.
Like how?
Well, throughout history, new technologies have always led to new forms of art and expression.
That's true.
Give me an example. The printing press photography, the internet, they all sparked fears, but ultimately they expanded human creativity.
You're right. So maybe AI is just the next chapter in that evolution.
I think so. Instead of fearing it, we should embrace it as a tool, a collaborator that can augment our creativity.
I like that, a collaborator.
Yeah.
So looking ahead, what are the most crucial steps we need to take to ensure that the future of AI is a positive one that benefits all of humanity?
Ethical considerations have to be at the forefront. We need to make sure these systems are aligned with human values and used for good.
Right. Transparency, accountability, fairness, those are all key.
Absolutely. And education is crucial too. We need to educate the public not just about the technical aspects of AI, but also the ethical and societal implications.
It's about fostering a generation that's not just tech savvy, but also ethically aware and socially responsible.
Exactly. And we need open dialogue and collaboration. This can't just be a conversation among researchers and tech companies.
We need everyone involved, policymakers, industry leaders, the
Yeah.
public. We all have a stake in this.
Absolutely. This is a global effort. We need to work together to create a future where AI benefits everyone.
This has been an incredible conversation.
Yeah.
So much to think about. Kimi K1.5 is clearly a major leap forward in AI capabilities.
It's a glimpse into what the future might hold.
And while there are definitely challenges ahead, there's also immense potential for positive change.
We have a real opportunity to shape this technology and use it to make the world a better place.
That's right. It's up to us to make sure that happens. Thanks for joining us on this deep dive into Kimi K1.5 and the future of AI.
It's been a pleasure.
And to all our listeners out there, keep exploring, keep questioning, and keep imagining the possibilities, because the future of AI is in our hands.